In this video, I want to have a look at how we can solve inequalities using graphs. So drawing a sketch of relevant functions can help us to solve equations and inequalities. So what we're going to do is we're going to sketch a graph of the left-hand side of the equation and the right-hand side of the equation, and then we can look at its points of intersection. So let's have a look at what that looks like in an example. Our first example asks us to graph the functions y equals x cubed and y equals x on the same number plane. So notice that this does say graph, not sketch, and that's because we want it to be accurate enough that we can read off the points of intersection. So we'll graph those two things. This one here is your standard cubic, and this one is a straight line with gradient 1 and y-intercept at the origin. So we've sketched both of those graphs. So the blue one here is the cubic, y equals x cubed, and the green line is our straight line with the equation y equals x. Part B asks us then to use the graph to solve the equation x cubed is equal to x. So we want to know when those graphs have the same value. So that's going to be where they intersect. So in this one, there's going to be 3 points. We're going to have this one down here. We're going to have this point here and this one here. So we've got 3 points of intersection. So we've got 3 values of x that satisfy that equation. So for part B, we would have x equals, this one down here is at x equals minus 1. We also have at x equals 0, and up here as well at x equals 1. So the 3 values that satisfy that equation. For part C, it asks us to use the graph to solve the inequality x cubed is less than x. So remember, our x cubed is our blue line, our x is our green one. So if we want x cubed to be less than x, we want any values of x on our graph where the blue line, our cubic, is below the straight line. So that's going to be this whole region in here, and it's also going to be over here. So in those 2 sections of our graph, the blue one's below the green line. So those values then, if we look at this one first, that's any x value that's less than minus 1. We'll have that graph underneath. We've got x is less than minus 1. And we also have this region here where x is between 0 and 1. We'll have 0 is less than x is less than 1. So anywhere in either of those regions, we'll have x cubed being less than x. Our second example, part A, asks us to solve the equation the absolute value of 2x minus 3 is equal to minus x plus 3. So to do that, we're going to sketch a graph of the left-hand side of the equation and the right-hand side of the equation. So the 2 graphs we're going to draw to graph are going to be y equals 2x minus 3, or the absolute value of 2x minus 3, and y equals minus x plus 3. So we want to graph those as accurately as we can. So we've graphed both of those lines. So the purple one here is our absolute value function, and the orange one is our straight line with equation minus x plus 3. So part A is asking us to solve that equation, so that's where our 2 lines intersect. So there's going to be 2 points, it's going to be this one here and this one here. So the x values that make that equation true are x equals 0 and x equals 2. Part B asks us to solve the inequality the absolute value of 2x minus 3 is greater than or equal to minus x plus 3. So that's when our absolute value graph is greater than our straight line, so when it's above it or equal to it. So that's going to be this region here and this one over here as well. So our x values that make that true then are when x is less than or equal to 0 and when x is greater than or equal to 2. So that's a few examples of how we can solve inequalities using their graphs.